Hello everyone and good day. I hope you are doing fine at your place, right where you are. So in this video, I'm going to present about my final year project 2, which is the characteristic of motorcycle suspension system. Okay, so before we start, I would like to introduce myself. My name is Brendan Vico Francis, and I am from FTK, and I am a mechanical engineering technology student with automotive in specific. So without further ado, let's go to the introduction of this project. So basically speaking, this project is about building a motorcycle suspension system by using a half-car model from a car basically into the simulation, into a software, as we know, which is the MATLAB simulating software. So by using this software, we can run the simulation and get the result from the software and from the result generated. Basically, this project is quite simple because I just need a study of a mass spring damper system, and by using the mass spring damper system, I will generate the half-car model that represent the motorcycle suspension system, as most of the researchers done in the studies of the half-car model of a vehicle to study the suspension system of the specific vehicle. So basically, the problem statement for this project would be when a motorcycle hits a bump, the bump will generate a vibrating force to the wheel, and then transfer the vibrating force to the passenger seats that affects the passenger driving comfort or ride comfort for the motorcycle. And not only that, it also affects the braking ability, the handling, as well as the safety of a vehicle when it comes to the suspension system traveling on the road, on a different profile of the road. Okay, so therefore I'm making this project, the simulation of this project, to study how the response of the suspension system of the motorcycle when the analysis is done in the MATLAB simulating software by using the half-car model from a vehicle and using the parameter of the motorcycle to actually run the simulation in the MATLAB simulating software. Okay, so there's only two of these objectives of this study, which is to develop a motorcycle passive suspension system by using a half-car model in a Simulink, and also to make an analysis of the half-car model of the motorcycle suspension system in the Simulink. And for the scope of this study and this project is there's only 3 speed of the motorcycle that is considered for this study simulation, which is the speed number 1 is 20 km and 30 km and 40 km per hour. And there is only one single bumpy road that is considered for this simulation of the study. So for the literature review for this study project, the main focus of the literature review would be the passive suspension system and also the degree of freedom for the half-car model. Okay, so what is the passive suspension system? It is the most common suspension system used in the field of automotive that includes the motorcycle. So the passive suspension system is the combination of spring and the damper system, and also the tire as the spring rate. Okay, so for degree of freedom is represented by the half-car model. The model is described by the vertical displacement of the front wheel, rear wheel, and the chassis as the bounds of the suspension. and also the rotation angle of the chassis, which described as the pitch of the rotation. Okay, so for the first one is the Halfcar modeling. So this Halfcar modeling is basically a mathematical model that represents the half car of the suspension of the motorcycle. So in this Halfcar modeling, it also represents the passive suspension system on the motorcycle for the front and rear. From this mathematical model, there is some of the letters that represents the sprung mass and unsprung mass, and also the spring and the damper system, as well as the tire, and also the force acting on it. So after we consider which one is the sprung mass and unsprung mass and all that, we can form it into an equation. And now we have talked about the equation from the mathematical model. Now we can consider the parameter that is to use for this motorcycle suspension system. Okay, so for the road condition, there will be a single bump to be considered. So the height of the bump is 0.075 meter and the width of the bump is 0.4 meter. Block diagram, it represents the whole system of the Halfcar model suspension system. So it also represents the sprung mass, the unsprung mass for rear and front, and also it represents the moment of inertia, which is the pitch of the Halfcar model. But before we going to run the simulation, there will be some calculation that needed to be considered as the step input. So the calculation would be the motorcycle, the speed of the motorcycle travel for 20 kilometer and 30 kilometer and for 40 kilometer. So by calculating the time required for the motorcycle suspension system to be on top of the bumper is needed to be calculated. So as I have already done the calculation, now the calculation can now be inserted in the step input of the Simulink. So this step input also represents that and the time required for the wheel to stay on top of the bumper during certain time duration. Okay, so the simulation will be run for 20 kilometer and 30 kilometer and also 40 kilometer per hour. The result would be the sprung mass and the unsprung mass for front and rear of the motorcycle, and also the moment of inertia, which represent the pitch. For the sprung mass, the result would be for 20 kilometer and 30 kilometer and 40 kilometer per hour. And then for each of the speeds, the kilometer speeds, the displacement and the velocity and also the acceleration will be considered as the result that is used to make an analysis of the behavior of the suspension system. Okay, so for the first result, which is the sprung mass, according to the result that have been obtained, it shows that as the speed of the motorcycle increase, the displacement of the reading of the sprung mass is much lower. This is because the increasing of the motorcycle travel speed is causing the bounce of the sprung mass to be much lower than the lower speed of the vehicle or the motorcycle travel, which causes more bouncing or more displacement to be happen in the sprung mass as it's travel on the lower speeds. And one of the factors that affects the bouncing of the sprung mass is the weight of the sprung mass itself. Now we proceed to the unsprung mass of the system, which is the front and the rear wheel of the suspension system. So for the result is, according to the result from the table that we have obtained, it shows that as the motorcycle speed increase, the reading value for the displacement, velocity and acceleration of the unsprung masses, it remains the same as the speed increase. So one of the possible reasons to this matter is that the similarity value of the tire stiffness from the both of the wheel. So we now proceed to the final result, which is the moment of inertia. The moment of inertia is the pitching of the motorcycle in a circular motion. So it is observed that the maximum reading value for the angular displacement seems to be decreasing from 20 km until 40 km. The result seems to be decreased, while the minimum value result seems to be increasing, as in 20 km up until 40 km. Now, the reason to this value results is probably because of the characteristic of the suspension system of the component and the parameter value from the lightweight of the suspension system component. Because when a motorcycle is traveling at a high speed, the chances to bounce on a bumpy road will be reduced, and it will give the less bouncing effect when a lighter of the suspension system component with a high speed travel by the motorcycle. The conclusion can be made, whereas the objective of this thesis study was to develop a motorcycle passive suspension system by using the Halfcar model applied to the suspension system of the motorcycle, and the graph generated shows the trend of the maximum reading for the sprung mass displacement is decreasing as the speed is increased. So therefore, the Halfcar model can be used on either on motorcycle or the vehicle to make an analysis for the suspension system for further study, which include the ride comfort, the vibration reduction, and the handling performance of a motorcycle. And that's all from me. Thank you.